Hello everyone, my name is Svetlana Isakova, and today we are going to talk about the Kotlin programming language. I am the developer of this language. This talk will be based on the book and the series of talks Java Puzzlers. Maybe you saw it or read the book? Oh, quite a lot, really nice. So if you didn't, it's worth it, just look it through. There are lots of examples here. But frankly, this talk will be a bit cheating, because it will be honest to compare Java puzzlers with Kotlin puzzlers, but we won't do it. Firstly, we don't know a lot of Java puzzlers yet, but I'll show you one. What we will do is we see how we fixed existing Java problems in new language. And what is interesting for us here is what can be fixed in the new programming language, new JVM language, and what cannot. But before we start, I want to make a small digression, because last time I gave this talk, it was in Russian. It was a bit easier, actually. Before the presentation, we had a small amount of time, and they asked me mostly one question: why do we need Kotlin? And I spent some time to answering it. Okay, then I gave the talk, everything was fine, and after the talk, they asked me, but see, why do we need Kotlin? And I understood, okay, maybe I wasn't really good at explaining these reasons. So now I want to start with some introduction, which aim is just answering this question. Why do we need another JVM language? Why don't JetBrains just invest lots of efforts in writing a good plugin for Scala or Groovy or something? I'll explain it. So, and then we'll have this Java parsers thing. So what is Kotlin? Kotlin is modern language for industry. Let's talk about first, what is Java really good for? Java is really a very good language for big projects, big companies, lots of code and big teams. And here is an interesting question. What is so special about big projects and big teams? The thing is, then you have to read code much often than you have to write it. Because imagine you have a big project and you have to change something in this project. And first of all, what do? You just read the code, trying to find what is going on in this code and what do you have to fix in this code. So I have to read a lot of code. And an interesting question appears. Maybe we can have more simple language that can help us to have more readable code, just to make us easier to read this code and understand what is going on. So again, what is our goal as language developers? We want the language that we want for our code to contain enough information for us as developers, as readers of this code, but not more. Okay, I'll show you some examples. The first one, I think, is a very illustrative example of what I'm trying to explain. Now, this is the old Java for loop. And the second one is a more modern loop that we have basically in new modern versions of Java and all these new languages. But what's important here, the second version is much more readable. So when we see the first one is not very difficult as well. So we said, okay, it's just a loop, but it is a more complicated pattern. And we have to spend a bit more time to understand it, to see, yes, it's just a loop. And there is a nice example. Sometimes it happens. Sometimes I want to iterate over a loop with an index. And in Java, I don't know the easy way to do it. There are lots of ways, and there is one of these. But here I have to have special variable that I have to increment explicitly. But what could I possibly want to have here is something like the second example. Just a more simple pattern that shows us that it's just iterating over a loop with an index. Then an example that I think appears in all introduction to Scala docs. And there is a question. What does this code do? And actually, their answer is nothing. It just stores the data. And now we know how to express this pattern of just storing the data in a more concise way, in a more simple way. Again, there's an important thing. There is no much difference when you write this code. So I really hope that you do not write by hands all this code, all these getters and setters code. I really hope that you generate it. Who generates this code? Please yes, thank you very much. But the difference begins when we have to read this code and when we have to understand, oh, okay, it's just stores the data. And from Java point of view, the second example in Kotlin is just the same Java. It's just the same getters and setters. So it's like a syntactic sugar over Java code, but that really helps us to have more simple code for us as readers in these big projects. And what is important? From my point of view, it is the similar thing for all these better Java languages. We want to help us as readers of the code. And what do we want to have? We want to have modern language. What do I mean by it? First of all, it's concise and then expressive enough for us. It should be concise because we're really fed up of all this boilerplate in Java that we have to generate and then it just is and we can think about it. But we want our code to be rather expressive, our language to be rather expressive to help us to avoid repetition and to extract all this recurring code in some libraries or in some common places. So, from my point of view, all these JVM languages satisfies these requirements of this conciseness and expressiveness better than Java. So we want to have something better than Java. And but then some differences start. When JetBrains started the project, one of the reasons why JetBrains did started. And developers inside JetBrains wanted to use this new better Java language for our own tools, for IntelliJ IDEA. So simply write IntelliJ IDEA in Kotlin. And what options did we have? We could possibly choose some dynamically typed language, but it turned out that dynamically typed languages are not very good for big projects because we have problems with IDEs, because they are not fast enough for us. So it should be a statical type language. Okay, then, but we have very serious requirement. If we want to write IntelliJ IDEA in Kotlin or some other existing Java project in Kotlin, we want to have really very easy Java interop. And that's important. What do I mean by it? Okay, in the next slide I have this special table when Kotlin has all pluses and no other JVM language has. And we see that all these languages are concise. So concise and expressive, that what we want, this better Java. But then let's look at the third line. This is about Java interop. It is very important for us to have to be able to invoke our code easily from Java, not vice versa. Vice versa is easy for every language. It's not difficult to invoke Java code from Scala, from Ceylon, or from Kotlin. But the difference starts when we have to invoke it from Java. For example, if you have Scala and you want to really mix some Scala code to existing Java problems, you will have dirty code in those part when you invoke Scala code from Java code. If you write in Scala code like in Scala way, using its own library, using option types and so on, it will be dirty code in Java when you try to invoke it. So it's easy to have some separate component written in your JVM language. But if you want to mix it entirely, to say something, I want to have a new class. What language should I choose? Maybe Kotlin. Okay, let it be Kotlin. And you won't have any problems with it. You won't have dirty code. The code that invokes this code from Java will be like Java code. So there is very important difference why there is no statically typed language that we can use in our JetBrains internal projects. So that answers why we don't just, make a good IDE for some other JVM language. Another important thing is that we want to have stronger type system than in Java. It means, what do I mean? We want to make some runtime errors, transform some runtime errors into compile time errors. For example, null pointer exception. All these JVM, Scala and Ceylon and Kotlin have their own ways to struggle with this problem, to avoid null pointer exceptions and to check it in compile time. But our approach is very easily Java compatible because we really need it in our projects. So it is the end of the introduction part. I'm absolutely sure that there are lots of you who will ask after this presentation, so why do we need Kotlin? But I hope that even some of you understood what I was trying to explain. Maybe if you have some questions here, I can try to ask. Not why Kotlin, some more specific. Okay, then the goal of the other part of presentation is honestly just to entertain you, because we have these Java puzzlers, and it's really nice book, and it's, I don't know, blows my mind something or something. So what is puzzler? Puzzler is some code that contradicts our intuition, that makes us puzzled. What's going on? The first example. Most of you, I'm sure, know the answer because you are Java developers. So the first thing, what I think when I see this code, I can suggest that the author meant comparing these two strings. So the first thing I do, I just count the chars in the first string. So it's 10. Then the second string will be the same, length 10. So it should print animals are equal true. But then I remember that no, in Java, equality comparison is reference comparison, not value comparison. So, but there is a special example in which these strings will be different objects. So it means that it should print animals are equal false. But what's the answer? The answer is just false. Why? Okay, we forgot about parentheses. Yes, that's true. But what is important for us here is that we all know Java, and there is classical question in the interview to a new Java developer about this equality and value comparison in Java, and we just used to have it. Another question from interviews about strings is, what can be wrong with this code? Maybe, what is the easy way to fix it? String S can be nullable, yes, and so it may throw null pointer exception in this case. And the easiest way is just to swap a receiver and an argument. That's easy. You all know it. It's obvious for us as Java developers. But what our intuition wants, honestly, my intuition wants just to have this comparison as equality comparisons. Because really, we very rarely need reference comparison if we have equals. And all these new JVM languages like Kotlin just has this ability just to write equality, and it will mean generating the right code for you about nulls and comparison, reference comparison, and comparison by equals. So it's just small thing, but very useful about these better Java languages. Oh, let's turn to an entirely different question. How to make this loop infinite? Ideas? Okay, I lied. It's absolutely the same question as previous one. Absolutely. There is no difference. The thing is that when we see this equality comparison, there is not equals. It means in Java, reference comparison, not value comparison. So we just can declare values of integer wrappers types, and it will have an infinite loop here. The same question about like with the strings, what can be wrong here? The same answer. The value might be null. And what can we possibly do here? In Kotlin, if you want to summarize two non-nullable integers, you just write it. But if you have a value that can contain null reference, you have to use another type, int with question mark. And compiler force you to check explicitly that you dereference it in the right way. So this is the way how we try to avoid null pointer exceptions. We have lots of ways how to use in a convenient way these nullable types, and they are easily Java compatible because they just compile into the same types as in Java. So in Java we can use annotations on these types, but in Kotlin we have these nullable types. I don't think it's clear, but I've tried. Okay, so what says our intuition about these numbers? We want these to be arithmetic operations on values. When we write these, we don't think about if it can be null or cannot. And Kotlin helps our intuition not to be puzzled here. Okay, another example. How to make this loop infinite? Most of you have read Java puzzlers, so you've already knew the answer. Where are you? When I was reading this book, I really liked, because this name E was totally disturbing for me. I really thought that it should be integer, but it's not. It can be double infinity, and the funny thing is that, yes, you can increment infinity and will be infinity. And the most interesting thing is about that you can have just very big, long number, and converting it to double, you'll have the same value. It's an example of a puzzler that we cannot fix, and we're okay with it. Because basically, these corner cases are not very important. So again, in the introduction, I try to explain why do we need Kotlin, and these puzzlers are not why do we need Kotlin. It's just some consequence of that we have it, and it fixes all these small issues. But these small issues are not very important, but they are just amusing. Okay, classical example from Java Puzzlers book. What can be printed here? So what options do we have? When I see this code, the first thought is that all three words can be printed. Pain, gain, or main. I can suggest that it is what the author of this code intended. But then I think, but it's puzzles, so something should be wrong here. Yes, and I start to think, and first I notice the number 2 in a random. So it will be only 2 options, yes? So it will be 1 and 2, and then pain and gain in the second option. But then, no, stop. Random returns us 0 or 1, yes? So it should be another case. It should be gain or main, but we don't have this option here. And then I remembered, yes, in Java switch should has break. Instead, we'll just fall through all the options and choose the last one. So it's main, yes? And what's the answer? Okay, none of the above. And there is an interesting question. What is the actual answer? Okay, I hope it's surprising for those who didn't read Java puzzlers. Are you surprised? No? Very good. I wanted you to be surprised at this moment. And what's the problem here? When we see there is a constructor invocation uString builder, we see actually here not the char, but this chart looks like the string. Yes, so it's what I think of it. But string builder has 2 constructors actually, with the int and with the string. And in Java we have this implicit conversion into primitive types. And here we just create string builder with different capacity. And then we'll add a, I, and n, and we'll get n as a result. Yes. What we should do it? What lesson can we have as language designers from this example? Let's avoid making some things implicit, like implicit conversion even on primitive types. Please, so in Kotlin, it forces us to explicitly write what constructor we want to invoke here. There is a name solution for this slide, but it's not actually a solution. But because if you want to write this code, you'd better write 3 constants and choose among them. But just trying to fix the bugs in this code, we'll have this example in Kotlin or in Java, and something like this in Kotlin. So it looks like similar, but we don't need this break thing. It turned out to be counterintuitive. So it's a small example of what decision we'd like to change after some years of experience with this really brilliant language. Okay, I think this example is looks like a girl. It's just indecisive. It doesn't know what to return. And actually, I don't even want to think what should be returned here, because it's not the right way to allow you to write this code. Please don't. We'd better to forbid it, just to not you get perplexed of it. So in Kotlin we have this unreachable error, and when we generate this error, we saw how what Java actually does in this case, and it will return, I think, false. Yes. So we are getting closer to one alone Kotlin puzzler. But before it, I have a question. How many woofs will be printed here? We have 2 options, I think, 1 woof and 2 woofs. It's very easy, actually. You all know it. You all know that static methods are not virtual, that is, they bind it statically, and that means even if we invoke static method by object reference, it will be static binding, and it means that we'll have 2 woofs here. Is it clear? Everyone agrees? No objections? Okay, so what was the problem in this code? The problem actually was that we allow us to invoke static method by object reference because it may sometimes perplex us. And what is the decision? What is the way to fix it? Just to avoid this invoking. Just to say, no, we can't invoke the member by object reference. And in Kotlin, we have special place where you put all your static methods, it's class object, and they are not mixed with the other methods. So there is, this one is, I'm sorry, this, everything's okay, is the one Kotlin puzzler for you. What does your intuition say you this slide? You don't know everything about Kotlin. And actually there is extension functions that help us to extend existing libraries, the feature that was stolen from C#, but maybe it's not very important here. So the question is the same, 2 wolves or 1 wolf? 1, yeah. 1, really? Do you think it will be 1? But no, it's wrong. It's yes. So it means that is a puzzler, that your intuition gives you a wrong answer here. But I checked for some people, their intuition gives the right answer here. So it depends on your intuition, on your Java intuition. So what is important here, that we can't change existing class. When we write this extension function, it's just static function in somewhere. And we have a very useful way to invoke it from Kotlin by this dot. And it will be in the completion list, and we'll be happy with it because we don't need to find it somewhere. But it will be only static function, and that's it. Okay, thank you very much. And Alexei will now tell you some more complicated puzzles about Kotlin. Thank you.
Thank you, Sveta. Hello, everyone. I'm Alexei Sidunov. I'm also a Kotlin developer at JetBrains. So let's continue with Java and Kotlin puzzles. Now time has come for some change. So I guess a lot of you remember this puzzler, yeah? Oh, that's quite interesting. Okay, so suppose you want to calculate the difference between 2 and 1.1 and write it as floating point values. So the question is, what the result? What does this code print? How many of you think that it prints 0.9? Okay. No, it does compile, but the problem is it prints something very close to exact answer, but not quite. What's the problem? The problem is that we're dealing with floating point numbers, and original numbers such as 2 or 1.1 can be represented exactly in a floating point format. So as a result, when we subtract those numbers, we get something very close to our assumed answer, but not quite. So what if we want to do exact arithmetic operations? We have one option we have is just to avoid floating point numbers at all. So we can just convert these numbers to integers, perform calculations with integer numbers, and then interpret the result as floating point numbers. So for example, we can multiply those numbers by 100, then do the subtraction and divide by 100 again. But what if we really do need calculation with fractions? What if we need arbitrary precision? In this case, we can use one class from Java standard library, which is called BigDecimal. And for example, if we want to implement previous calculation with BigDecimal, we can write code like this. And how many of you think that this code prints 0.9? Okay. It turns out that you're wrong. So what's the problem? The problem is basically the same. BigDecimal has multiple overloaded constructor, and one of the constructor we are using here is actually the one taking double argument. So BigDecimal trying to construct its internal representation of decimal number using floating point value, and since floating point value can't exactly represent 2 or 1.1, BigDecimal representation also becomes not exact. So when you do the subtraction, you get slightly more accurate result. It's more close to 1.9, sorry, 0.9, but it's not what we want actually. So how do we fix it? In this case, the simplest way to fix it is just to use another BigDecimal constructor which takes value represented as string, like this. And if we run this program, we see that now it prints correct answer, and even uses the same precision as our original numbers. So the problem here is that although this code works fine, it looks kind of ugly. It contains a lot of information noise. So originally, I just wanted to do the subtraction. Why should I need to write so much code? Why should I mention BigDecimal itself? So I would like to write it something like original expression, but in Java I can't. I have to construct to BigDecimal, I have to write subtraction, and then convert result to string. So how is this related to Kotlin? Actually, in Kotlin, you can write this code in much more concise way. So you can see this example. Well, actually, the only difference from original Java expression is that we use strings instead of floating point values, and this strange BD value. So what is this? Actually, BD value, you can see its definition below. It's so-called extension property. That is property which in this case construct a BigDecimal instance based on the string value. And Kotlin allows us to invoke this property as if it were a property of the original string class. So we can just write, for example, 2.00 as string.bd, and this will construct the corresponding BigDecimal instance. And the same goes for another string. And what about this minus? Both arguments are actually instances of BigDecimal. So how can we use minus here? The answer is that in Kotlin we have operator overloading. And overloading is implemented via special naming conventions. So for example, if you define a function called minus on the class itself or as an extension function, as in our case, then you can automatically invoke it as a minus operator in an infix form. So in our case, unfortunately, designers of BigDecimal didn't call their subtraction method minus. So in this case, we have to declare extension function, which basically is just a wrapper for existing subtract method. But then when this function is a scope, we can just invoke subtraction using well-familiar minus operator. Okay. Let's look. Yeah?
Are you still using requiring the string format?
What?
For the subs? So you use string?
Well, do you mean if we can use actual floating point numbers instead of string? Well, we can, but actually this would be equivalent to this code. So the problem is not in the Java itself, but in the floating point number format. So we can't exactly represent number 2 as floating point. So if we convert it to double, for example, we lose precision. The advantage of Kotlin is that it allows you to write such calculations using strings and BigDecimal in a more concise way than Java does. Okay, let's look at another example with numeric comparisons. And in this case, the original puzzle is called strained relation. So by relations here we mean equality. And what is strained here? Of course, you remember that equality, for example, equality consort with numbers, as any equivalence operator must satisfy some properties. That is, it must be reflexive, it must be symmetric, it must be transitive. For example, if you looked at the documentation to object equals method, yeah? How many of you looked? Okay, so if you look at the documentation to object equals method, you can see several rules which must be, which are recommended, strongly recommended to be satisfied when you write your own implementation of the equality, for example, for your own objects. And in particular, equality must be reflexive, that is, x must be always equal to x. It must be symmetric, that is, when x is equal to y, y should be equal to x. And it must be transitive. That is, when x is equal to y and y is equal to z, then x must be equal to z. It turns out that for numbers, equality is somewhat complicated. So, for example, you can't get reflexive equality when you're using floating point numbers because of so-called not a number. Do you know about not a number? Okay, so you know that characteristic property of not a number that it is not equal to itself. So it does violate reflexivity of equality relation. But here we would like to deal with another property, namely transitivity. So suppose we write code like this. So we have two variables. We have three variables. One of them of type double and two of type long. And we deliberately select such big numbers in order to demonstrate that in some cases equality doesn't behave as our intuition tells us. So, for example, if we assign x to max value of long, and then convert this value to double and assign it to y, and assign value which is which is equal to max long value minus 1 to z, and then we are trying to compare those numbers pairwise. So, as a result, we should as a result, we get 3 Boolean value. What do you think is first value? True. Okay. Well, it should be pretty obvious. So we are comparing long with double. Since one of the numbers double, then long is also promoted to double. And so basically we are applying the same conversion, that is conversion to double, to the same value. So basically in this expression we are comparing the same double value, whatever it is. Okay, what about second? True or false? How many for true? No one? How many for false? Okay. Well, it seems pretty obvious that these numbers should not be equal. Well, actually, it corresponds to our intuition. But let's see. And what about the third one? Well, it should be obvious. We are comparing two integer numbers. One is less than other, so the result should be false. So why second comparison is true? Sorry? Here? So what do you mean? No. Conversion rules are the same. So here, in the second expression, you are also comparing double with long, and evaluation rules in Java say that if one of arguments is double, then all other are promoted to double. So in this case, our argument z is promoted to double, and it looks like when this value and this value are promoted to double, we get the same result. Why is that?
The value changes in full conversions.
Yeah, exactly. So the problem is that, as I already said, we deliberately selected such big values. And it turns out that long.max value is so big that it doesn't fit into double exactly. So when you convert this value into double, it gets rounded down to the maximum finite value represented as double. And the problem with floating point representation is that the bigger number magnitude, the bigger difference between adjacent numbers. So for numbers which is as big as max finite double value, the difference between adjacent numbers is way bigger than 1. So it means that when we convert in long max value or long max value minus 1 to double, we get the same result. So when these numbers are converted to double, they are equal. That's why second expression evaluates to true. So we see that in a mixed computations, when we use both integer and floating point numbers in the equality, its sensitivity can be broken due to conversion problems. So if you remember that, in Java there are some automatic widening conversions, which can lead to loss precision. So in this case, we have an example of such conversion when we translate long to double. Yeah.
But is this, you're specifically casting the long value to a double. So basically, you're saying, I'm okay with the precision loss.
Yeah.
Then, in my opinion, it isn't that strange that you get a different result, because you're explicitly saying, I'm trying to fit this really big thing into a smaller thing.
Yeah, but this well, actually,
Because if it was an implicit
yeah.
conversion, I would agree. Then it would be strange. But now you're saying, I know I have a long, a really big thing. I'm trying to fit it into a double, or for that matter, into an int.
Well, the problem here is that, yeah, of course, you are explicitly converting long to double, but the problem is in this code. It is not. It is counterintuitive. You are comparing you're comparing three numbers, and by looking at this code, we are expecting that this relation to be transitive, or at least if it can be evaluated, the compiler should report an error in this case. So it's not safe to compare. Sorry, not safe. It's not. It's counterintuitive to compare integer number with a floating point number. So in this case, it would be better if we could explicitly convert long number in this expression also, convert long number to double one. So basically, this is exactly what we say in Kotlin. So to summarize the problem in this example, you can see that first and second equality are imprecise because they involve long to double conversion, and the third one is precise because it deals with integer number. Okay, so what do we have in Kotlin? If we try to write this example in Kotlin, then we get an error here. And what does it say? It says that operation is not applicable. Why is that? Because here we're trying to apply equality operation to numbers of different types. In this case, to numbers, one argument is a long value and another is double value. So in this case, your program will not compile, and you'll have to manually cast of one of your variables to corresponding type. So for example, we can cast variable x to double, and then comparison is okay.
So you want to have it less concise in that case?
Yeah, because in this case, we believe that in this case, we believe that developer should explicitly say what he wants to see in this code. So in this case, less concise is better, actually. Okay, now let's look at some class puzzles, and one of them is private matter. So this actually is pretty simple. Suppose we have some class base with a public field called class name, and we initialize it to base. And then we have a class derived, which is inherited from base, and declare a field with the same name, but now it's private. Suppose that we then write some third-party class, which is called private matter, which tries to construct instance of derived and then access its class name field. So what do you think it prints? Okay, so who vote for base? Okay, who vote for derived? Who vote for something else? Okay, actually the program doesn't compile. It doesn't compile because here the compiler assumes that you are accessing field of the derived class, and since it's private, it can be accessed by third-party class private matter. So what is the problem here? The problem is that you have field with the same name, and generally when you are declaring something with the same name, for example, if that's a function, it's a method in the subclass, you are supposing that you are overriding, that you are replacing something, some existing behavior or some existing part of parent class. But in case of field, it's not true, and it turns out that if you declare a field with the same name, regardless of its access level, it just hides original declaration. So you can't access original field of the class base, in this case, in private matter class, unless you explicitly cast this expression to type base. But the key problem here is that you do not see an error when you just define your base and derived class. You only see it when you try to use it in some third-party class. In Kotlin, we have slightly different behavior. First, in Kotlin, we do not have true fields. You can declare a field in a Kotlin class. You can only declare a property or a function. And property behave much like function in Kotlin or methods in Java. So they cannot be hidden. They cannot be overridden in a subclass. So in this case, when we are trying to declare a subclass of base and we define a property with the same name, we get an error. We get an error, and compiler says that we can access privilege. The problem here is that original property is public, and we're trying to overwrite it with a private one. So in this case, we get an error when, as soon as we are trying to declare derived class, not when we are trying to use base or derived in some third-party classes. So compiler, in this case, compiler helps us to catch a potential bug early. By the way, in this case, there is one more error. Actually, you can see that original class is declared with open. That's because by default classes are final in Kotlin. So in order to make class inheritable, you have to explicitly declare it as open. And you can see that we didn't place open modifier into class name declaration. So it means that class name property can be overridden. And even if we fix public modifier here, compiler will still report an error because we're trying to override final property. Okay. Excuse me. Yeah. So with respect to access privilege, it's the same as Java method. So you can, when you override in something, when you, for example, override a method in Java class, you can assign it to, you can use either the same level of access or a higher one. The same goes for Kotlin functions and properties. Okay, now it's time for shades of gray. What do we have here? We have some class X. And in this class, we have two static members with the same name. One of them is static class with its own field Z. And another is a static field which has type C, and class C also has its own Z field. So in this setting, expressions such as x.y.z can actually mean one of two things. It can either refer to field Z declared in the static class Y, or it can refer to the field Z of instance of the C class declared as static field Y. So what do you think it prints? Who votes for white? No one. Who votes for black? Who votes for gray? For purple? Okay. Who votes for this program doesn't compile? Okay. It turns out the program does compile, and the answer is white. Why is that? Actually, when you have name clash with a class and field having the same name, compiler always prefers a field. So in this case, x.y.z actually refers to this y and this z. But this behavior is kind of counterintuitive because when we look at this expression, we can't actually make a preference. We can't decide which static member is more worthy than other. So in this case, Java choice looks kind of arbitrary. And in Kotlin, we forbid such declarations at all. So if you have two class members with the same name, for example, you have property Y, and you have class Y. Here it is declared in the class object as an analog of Java static declaration. And in this case, when you are declaring such members, you get an error. And you can see that you get this error even before you're trying to use class X or class X.Y. In this case, compiler reports that you are having a redeclaration. Two declarations with the same name Y. Okay, and finally, let's consider one more example of name clash. In this case, it's so-called import duty. So suppose we have some class, and we want to print the content of array. In this case, we are passing integer numbers to vararg parameter. So actually what we get here is an array of boxed integers. And then we are trying to convert it to string. As you know, default implementation of string is not usable for arrays just because they don't implement object to string. So, but you may also remember that there is another toString, static toString method declared in the Java util arrays class, which can provide pretty good representation of array, in particular array of objects. So we're trying to invoke this static method. We do static import first, so we can refer to this method by its simple name, and then pass our vararg to this method. So, do you think that this method prints 5 numbers? Yeah, that would be good, but that would be too simple. It turns out the program doesn't compile. Why is that? The problem, well, error message can be kind of cryptic, because here compiler says that toString can be referenced from static context. And the problem, and it happens because when you are trying to use toString in the scope of class import duty, and class import duty has its own toString method, which is inherited from object. And even though we don't declare it explicitly, it's just inherited. So, and it turns out that when you have a name clash of imported declaration and inherited declaration, Java compiler always prefers its own or inherited declaration. So in this case, we could say that Java's import duty is so high that that all imported goods are completely expelled by domestic ones. Okay, so formally we can say that toString array declared in Java util arrays, toString method declared in Java util arrays is shadowed by toString of import duty. What do we have in Kotlin? Well, in Kotlin this example compiles just fine and gives correct answer, because in Kotlin both imported declarations and local declarations and declarations inherited from superclasses such as toString are having equal opportunities. So their both are used in overload resolution. And in this particular case, when we're invoking toString on the original array, we're using correct method and printing the array content. Okay, yeah? What happens if they have the same signature? Well, I suppose it would be a resolution error, right? Yeah.
Okay, thanks a lot. We really wanted to show you lots of Java puzzlers, so we have not very much time for questions, only 3 minutes actually. But what I want to say, if you have any questions about Kotlin, if you want to discuss something, and I expect you have a question, why do we need Kotlin? It's Cerberus. So if you have any questions, you can go to our booth, in JetBrains booth, and we'll be very happy to answer all your questions. And there are lots of people who really like to talk about Kotlin for you. So we have 3 more minutes, and if you have any questions, please ask us. I'm sorry. Yes, I think every new these better Java languages have closures. It's how can we do it without them? More questions?
We have simple closures, and we also have extension closures.
Yes. More questions? Why do we need Kotlin? Yes?
Normally people don't write programs in a way like you described here. I don't have usually the class XYZ and static property XYZ. And in Kotlin installing salt in Kotlin looks a bit controversial because I don't
Yes. there was a question about what we showed you in this talk was not questions, were not examples from the practice. We don't write usually classes named x, y, z, and do have these problems. And I warned you about it. I warned you that this was a talk just to entertain you, but most of all. And in the beginning, we told about why do we need Kotlin. And later, we just saw some small examples of these corner cases with Java that we fixed it. But it's not the reason why do we want to use Kotlin, most of these examples.
But still, if you encounter such a corner case, like implicitly casting and then having something to do with it because you're not used to it, you still would be puzzled and spend a lot of time solving it. So I can
Yes.
see some
So we won't cope with these puzzlers usually in life, but sometimes we have to, and we want to avoid it as well. So it's not very important, but sometimes we are happy not to have these puzzlers in the code, something like this. So I'm afraid we are over time. So thank you very much for your attention.
Thank you.
If you have any questions, we'll be happy to answer it in our booth.